So hi guys, welcome again. So in this session, we will be learning about random forest, which is one of the most powerful machine learning algorithm. So random forest uses a technique known as bagging, which is an ensemble method. So before you learn about random forest, you need to first see what an ensemble is. So an ensemble refers to a group of things viewed as a whole rather than viewing it as individual. In an ensemble, a collection of models is used to make predictions rather than individual models. Arguably, the most popular in the family of ensemble is random forest, which is an ensemble made by a combination of large number of decision trees. So in principle, an ensemble can have various models such as logistic regression, decision trees, neural networks, etc. etc. Now, before you understand how ensemble works, the following question may arise. How does a collection of models works better than individual models? And how do you choose individual models to form a collection of models such that it is better than any of the individual models? So there are two things that govern the principle. One is diversity and other one is acceptability. So consider a team of players playing football match. If you were to choose how a football team is to be constituted, then what you would see, one thing has to be diversity, like out of those players there has to be defenders, there has to be attackers, right, which will play in the front, and a goalkeeper. What about acceptability? You need to choose good players, as in you have to ensure that all players are acceptable in point of view of their skill set and at least better than a regular player, right? So diversity ensures that models serve complementary purpose, which means that individual models make predictions which are independent of each other. Acceptability implies that the model which has been created is better than any random model. This is a pretty lenient criterion for each model to be accepted in the ensemble. So there are a number of ways you can bring diversity into your model. Use different subset of training data. Use different hyperparameters, use different type of classifiers, and use different features. So let's look on to some of the popular approaches of ensembling: voting, stacking, blending, boosting, and bagging. So voting combines the output of different algorithm by taking vote. So in case of classification model, if majority of the classifier predict a certain or particular class, then output of the model would be the same class. In case of regression problem, the model output is average of all the model predictions made by the individual models. In this way, every classifier or regressor has equal weight or equal say in deciding the output or the final prediction. Another approach to carry out manual ensembling is to pass the output of the different algorithm or different models to a level 2 classifier or regressor as derived meta features, which will decide what weight is to be allocated to each of the model output in the final prediction. In this way, output of different models are combined with different weights to get a final prediction. So this is the high level approach behind stacking and blending. Let's move on to boosting, the next ensemble technique. So boosting is one of the most popular ensemble technique. So what it does, it creates a sequential model to make weak learners as the strong learners. Now the next and the final approach to ensemble is bagging, which is also called as bootstrap aggregation. So random forests are built on this approach, which is very powerful in reducing the variance of the algorithm. So what bagging does, it creates a different training sets of data from sample training data, and an algorithm of same type of hyperparameters are built on these different training data sets. In this way, the same algorithm with similar type of hyperparameters is exposed to different parts of training data, resulting in slight difference in the individual models. So prediction of these individual models are taken on case-to-case basis. For classification, an average vote is taken. For regression problem, average of all values of models. So bagging works well with high variance algorithm that is easy to parallelize. By high variance means the model is likely to change a lot when a small change is done in its hyperparameter. Recall that similar case you saw during the hyperparameter tuning of decision tree, right? However, it has got certain disadvantages as well. In ensemble, you cannot see the different trees, working side by side. So behind an ensemble, there are lots of decision trees. This leads to loss of interpretability also. If there is feature domination in the model, then it does not work well. Sometimes bagging can be computationally very expensive. So going further, let's understand how random forests are built on certain algorithms. Hi guys, welcome to the coding part. So for importing random forest classifier, we need to import it from sklearn.ensemble. This is the library from where we have to import it. So as I told you, a random forest is an ensemble machine learning method that combines many decision trees to make more accurate and robust predictions. Now RF equals random forest classifier, random state equals 42 and estimator equals 10, max depth is 3. This creates a random forest model and we are giving different parameters such as random state 42. It ensures that the results are reproducible, like the same trees are created every time. And estimators 10 means the forest will consist of 10 decision trees, and max depth ensures the depth of the trees will be limited to 3 levels. So this will help in overfitting and keeps trees simple for visualization, right? Next is rf.fit. This command trains or fits the random forest model on the training data. So here xtrain is feature data, that is inputs, and ytrains are label data, that is output or targets. What is this command? rf.estimators underscore 0. It accesses the first decision tree in the forest. So estimator underscore is a list of all individual trees in the random forest. So this is the indexing part. It will start from 0 up to 9 as there are total 10 decision trees. Sample tree equals rf.estimators underscore 4 means it will select the fifth decision tree, that is index 4. Here is the tree which is created. So this is the fifth tree, sample tree. We can also access the third tree. Second index means third tree. So this is the third tree. Now let's evaluate the model. So it will evaluate how well the model will perform. So here the train accuracy is 74% and the test accuracy is 61%. So this is all with respect to the random forest classifier. Okay.